Suppose we have the square root of 3x plus 6 equals x. Remember in the last example, I mentioned that it was important to leave the radical on one side by itself. So let's take everything else to the other side. So we're going to leave the square root of 3x on the left, add a negative 6 to both sides, and so on the right we have an x minus 6. And at this point, we're going to square both sides. Squaring the square root of 3x equals x minus 6, the quantity squared. But at this point, remember that we may have introduced solutions, and so we need to check solutions. All right, but now this process of squaring the square root of 3x removes the radical, and we have a plain 3x. On the right-hand side, we've got a binomial. Be really careful with binomials. When you square a binomial, it might be good for you to write it as x minus 6. Then multiply that out to get x squared minus 12x plus 36. I've seen too many times students multiplying, squaring a binomial and ending up simply with x squared plus 36 and forgetting the middle term. So the middle term is very important there. All right, so now what are we left with? We're left with, we've seen before that perhaps we can solve this quadratic equation by factoring. And so in order to solve by factoring, we're going to have we have 0 on the left equals x squared. We're adding a negative 3x to both sides, so that will give us a negative 15x plus 36. Now, the next step in solving a quadratic expression by factoring is to see if we can factor this expression on the right-hand side. It's a trinomial. It has a plus before the last term, so that says the signs are going to be the same, and this tells us what they are. They're both going to be negatives. Here. And now, since both of the signs are the same, the middle term is the sum of two negatives, and in this case, factors of 36, which give us a sum of 15, what are they? 12 and 3 will work, right? 12 times 3 is 36, and 12 and 3 is 15. So we have x minus 12 times x minus 3. But, again, as the recommendation that you have had throughout this course is x we need, minus 12 times minus 3 is the 36 that we need. All right, so now we can say either x minus 12 equals 0 by using the 0. Now, the potential solutions, and don't forget, these are only potential solutions. If there are any solutions to our problem, we're going to find them among these, but until we check, we cannot say that these are solutions. So the potential solutions are these two. So when we check the solutions in the original problem, remember that the original problem was the square root of x equals 12. We'll substitute it in for the variable. Square root of 3 times 12 plus 6, is this going to be equal to x, which is 12? That's what we want to know. Well, this is 36, and so the square root of 36 is 6. 6 plus 6 does equal 12, and x equals 12 is a solution. It checks. Let's check x equals 3. When we substitute into the square root of 3 times 3 plus 6, is this going to be equal to 3, to x? And x, we're saying, is 3. Well, here we have the square root of 9. That's the same thing as 3. 3 plus 6 is obviously not equal to 3, and so that means we have to throw x equals 3 out. X equals 3 is called extraneous solution. What that means is that in the process of squaring both sides, what we did was we introduced a new solution to the system. So the original problem was the square root of 3x plus 6 equals x. Right over here at this point, we introduced the solution x equals 3. It is a solution to this equation right here, to this quadratic equation, but that wasn't the original one. And so we have to go back and check. Since it's not a solution to the original, we throw it out. It's an extraneous solution. The only solution that we have then is x equals 12. All right. And this is one reason that I call these solutions potential solutions, because if we have any solution, it will be one or both of those. Suppose we have the following. Solve the square root of 2t minus 4 equals, okay, we've got a square root. Well, that means that we need to eliminate that square root, and to do that, let's isolate it on one side of the equation, but it's already isolated, so we don't need to do anything else with that. Now, we're going to square both sides. The square root of 2 the quantity squared. Right? T minus 4. Just as I mentioned before, for t minus 2 the quantity squared, it is convenient to write it like this so that you can multiply it out. Minus 4t plus 4. That equals 2t minus 4. Have an awfully lot of equal signs here. Quadratic equation here. If we can solve that, the only technique we have at this point is to do it by factoring. So let's leave one side equal to 0. Let's remove everything to the other side. So we'll add a negative 2t, 6t. We'll add a positive 4 to both sides, and that will give us an 8. Now we've got a quadratic equation. Same, and they're both negative. So we have a negative here. We'll have t times t for the t squared. And because both of the signs are the same, we need factors of 8, which give us a sum of 6. Well, those are 4 and 2. So we can say either t minus 4 equals 0 by the zero factor property, or t minus 2 equals 0. So once again, the potential solutions are t minus 4 equals 0, that means t equals 4, or t minus 2 equals 0, which means t equals 2. But they're potential solutions, so we need to check. So let's consider again the original problem, which in this case 2t minus 4 equals t minus 2. Let's take t equals 4. Substituting it for the t inside the radical, we have the square root of 2 times 4 minus 4. So is this equal to t, which we're saying is 4 minus 2? Well, on the right we've got a plain 2. On the left we have 8 minus 4. The square root of 4 is equal to 2, and so t equals 4 checks. Of 2 times 2 minus 4, is this going to be equal to 2 minus 2? Well, this is 4 minus 4. The square root of 0 is 0. 2 minus 2 is 0. So this one checks. It turns out in this case that we had two potential solutions. Both of them check. This problem is the set which contains the solution 4 and the solution 2, or we could simply write these as t equals 2. Both of them check. Okay. All right, let's then do a summary of this. In order to solve equations containing radicals, with the radicals on one side of the equation, use the property that if a equals b, then a to the nth equals b to the nth. So with square roots, we're going to square cube both sides and so forth. We'll solve, and then we'll check all the solutions in the original equation.